A worker uses a forklift to move boxes that weigh either 40 or 65 pounds each. Let X be the number of 40-pound boxes and Y be the number of 65-pound boxes. The forklift can carry up to either 45 boxes or a weight of 2,400 pounds. Which of the following systems of inequalities represents this relationship? Okay, so we know that the total number of boxes can't exceed 45 boxes. And if we know that there are X 40-pound boxes and Y 65-pound boxes, then we know that the total number of boxes, which is X plus Y, can't exceed 45 boxes, which is the limit. And then we know that the forklift can also either carry up to 2,400 pounds. So if we know that the total weight of the 40-pound boxes would be 40 pounds times the number of 40-pound boxes, and we know that the total weight of 65-pound boxes would be 65 pounds times the number of 65-pound boxes, then we know that this total weight must be less than 2,400 pounds. And this information matches with answer choice A. A function f satisfies f2 equals 3 and f of 3 equals 5. A function g satisfies g of 3 equals 2 and g of 5 equals 6. What is the value of f of g of 3? Okay, so for questions where you have composite functions, what you first do is you solve the function that's inside the outer function. So if we have f of g of x, we would first solve this g of x in the middle and then have a final result for f of x. So the question asks us for f of g of 3. And in the beginning of the question, they state that g of 3 equals 2. So then all we have to do is plug in this value for g of 3, which is 2, back into f, and we have f of 2. And then the question also gives us that f of 2 equals 3. So then your final result for the value of f of g of 3, which is also the result of f of 2, is equal to 3, and that's answer choice B. Question 11 gives us a table and asks, Tony is planning to read a novel. The table above shows information about the novel, Tony's reading speed, and the amount of time he plans to spend reading the novel each day. If Tony reads at the rates given in the table, which of the following is closest to the number of days it would take Tony to read the entire novel? So we know that Tony reads at rates given in the table, which is what the question asks. So let's go to this table and find out what the rates are. So I know when I see the word per, that indicates a rate. So we know the number of hours Tony plans to read the novel per day, and also the number of words that Tony reads per minute. Okay, so now using this rate, let's try to find out how many words Tony reads per day. So we know that the number of words he reads per minute is 250, and we know that there are 60 minutes in an hour, and he plans to spend 3 hours each day reading the novel. So let's use our calculators and figure out how many words he can read per day. Okay, so we find out that Tony reads 45,000 words of the novel per day. So we want to find out how many days it would take him to read the novel. So all we would have to do is divide the total number of words in the novel by this rate of words he can read per day. So now let's look back at the chart. We see we have number of parts, chapters, pages, and right here, the number of words in the novel, which is the relevant information we need. So you can see actually the number of pages, chapters, parts are irrelevant for solving our problem. So if you're on the test, you can actually, cross that out yourself. A lot of the times in these SAT problems, they'll try to trip you up by adding extra information you don't need, and if you're not reading too carefully, you might get confused. So what you really want to do is be careful, and we know now that we only need this information and these two sections that indicate the rate. So we know that he wants to read a total of 349,168 words, and he can read 45,000 words per day, so that gives us 7.76 days for Tony to read the entire novel, and that would round up to approximately 8, which is answer choice B. On January 1st, 2000, there are 175,000 tons of trash in a landfill that had a capacity of 325,000 tons. Each year since then, the amount of trash in the landfill increased by 7,500 tons. If y represents the time in years after January 1st, 2000, which of the following inequalities describes the set of years where the landfill is at or above capacity? For these types of questions, I like to write down what I believe the answer to the expression or the equation would be before looking at the answer choices myself. So let's use the information in the problem to get started. So we know on January 1st, 2000, there are 175,000 tons of trash in the landfill with a capacity of 325,000 tons. So even at the onset, we know we need the amount, this is the amount, in the landfill to be less than 325,000 tons. So obviously at first, 175,000 is definitely less than 325,000. But each year since 2000, the amount of trash in the landfill increased by 7,500 tons per year. And we know Y is representing the number of years since 2000. So we know each year we want to add 75,000 tons and there are Y years. So then the total amount in the landfill would be 175,000 plus 7,500 Y. And we know we want this total amount to be less than the capacity of the landfill. So then the answer choice that matches this equation would be D. This inequality is D. A researcher conducted a survey to determine whether people in a certain large town prefer watching sports on television to attending a sporting event. The researcher asked 117 people who visited a local restaurant on a Saturday, and 7 people refused to respond. Which of the following factors makes it least likely that a reliable conclusion can be drawn about the sports watching preferences of all people in the town? Okay, so we know that when we're conducting a random survey to find out something in our investigations, we want the survey to be across the population as randomly as possible to make sure that our results aren't biased. So first, even by looking through this question, we can see that there's something a little bit off, because the researcher asked people who visited a local restaurant on a Saturday, and the amount of people who visited the restaurant on a Saturday can be maybe they just came back from the same sporting event, maybe they went to the restaurant to watch the game. So we don't know whether or not there are other factors that influence if they're at the restaurant and the results of the survey. So we know that this isn't completely random because the researcher asked 17 people who were in the same space at the same time. So in order to conduct a better survey, the researcher would ask people across a lot of different locations and across a lot of different days just to make sure there aren't a lot of other factors influencing why these people might be in the same restaurant on a Saturday. So we can see that where the survey was given would definitely affect the randomness of our results. According to the line of best fit in the scatter plot above, which of the following best approximates the year in which the number of miles traveled by air passengers in country X was estimated to be 550 billion? So this question is testing how well we can read graphs. So if we see this graph right here, we see the title, it's a graph of miles traveled by air passengers in country X from these years to 2005. And then on the x-axis, we have the year from 1960 to 2010 in increments of 10. And on the y-axis, we have the number of miles traveled in billions. So the question asks, in what year is the number of miles traveled by air passengers in the country estimated to be 550 billion? So for this, we're given how many miles the passengers traveled, which is 550 billion. So all we have to do is go to the y-axis, where we have 550 billion, which is the units, miles, and then we see what x value corresponds to that point on the line of best fit, and we can see here it's between 2000 and 2005, so I estimate this to be around the year 2003, and that is answer C. So for these types of problems, make sure not to be tripped up by the units on the axes, and make sure that you know what increments the chart goes by so that you can match your information correctly. The distance traveled by Earth in one orbit around the Sun is about 580 million miles. Earth makes one complete orbit around the Sun in 1 year. Of the following, which is closest to the average speed of Earth in miles per hour as it orbits the Sun? Okay, so we're given that the distance traveled by the Earth in one orbit around the Sun is about 580 miles. And Earth makes one complete orbit around the sun in 1 year. So we know that it travels this distance in 1 year. Okay? But our final rate we want to get is in miles per hour. So how can we convert year to hour? Well, we know that in 1 year, there are 365 days. Okay? So how do we get to hour from days? Well, there are 24 hours in 1 day. You can see what I set up here is kind of inequalities for 1 year is equal to 365 days and 1 day is equal to 24 hours. And the reason you want to do this is because ultimately you only want miles per hour. So then the units you have here can cancel out with each other. For example, if I have 1 year on top and also 1 year on bottom, I can cancel those units out. And if I have 1 day on top and day on bottom, then I can also cancel those units out. So then all we're left with is miles per hour for our units. And for that result, we just need to do 580 million miles over 365 times 24 hours. You can see for this 365, now it's unitless because we canceled out the day unit. So then, after you plug it into your calculator, your result will be approximately 66,210, and that corresponds to answer choice A, which is approximately 66,000 miles per hour. We have word algebraic problems, I like to call them, which is easiest just to follow through step by step and then write down what you believe the result will be and then see if any of the answer choices match. So in the questions we went over today, there are a couple of tables and charts. So for these, you just want to make sure that you read your information carefully and make sure you know what the question is asking exactly. And for surveys, the best practice for a survey is for it to be random, so with no bias in your survey. Finally, for conversion problems, such as number 15, where you want to convert the miles per orbit to miles per hour, you can use proportions and cancel out units.